Hey guys, welcome back. We're going to do some fun graphing of trig functions today. So we are doing section 4.6, which is all about graphing all the other trig functions that we had. So last time we did sine and cosine. So now we're going to look at, just to get our objectives out of the way, we're going to look at tangent, cotangent, and then we're also going to look at secant and cosecant. So we're going to look at how do we graph those four. And then we're going to sketch the graphs of damped trigonometric. Oops, I forgot the I. Spelling is hard. So we're going to look at damped trig functions as well, and we'll look at what that means. So we're going to start with tangent. Okay, so again, we're going to think back to the unit circle. Right? Think back. And we are going to look at the tangents of values at the unit circle. So the tangent at 0, so again, if it helps, sometimes it helps, right? At 0, we have the point 1, comma 0. So tangent would be 0 divided by 1, which is 0. So the tangent here is 0. At pi over 4, I have root 2 over 2, comma root 2 over 2. So the tangent there, right, anything divided by itself, the tangent is going to be 1. At 1.57-ish, right, and I can do that on my calculator, because remember that pi over 2 and 1.57 are extremely close to each other, right? So this would be like the rounded decimal version of pi over 2. Because at pi over 2, my point is 1, comma 0. Oops, sorry, that's not right. You guys are like, this crazy lady doesn't know what she's talking about. It's at 0, comma 1. So when I go to divide that, I get undefined. So right here at pi over 2, it's undefined. And we'll talk about that here in a second. But if I were to plug 1.57 into the calculator, I get 1,256. Just to show you it's increasing, it's getting really close. It's going up towards infinity. Okay, if I go the opposite direction now, negative pi over 4, very, very similar, except it's going to be root 2 over 2, negative root 2 over 2. So the only difference is my tangent's going to be negative 1. Again, at negative pi over 2, I have this point 0, comma negative 1. Well, negative 1 over 0 is undefined. So again, at pi over 2, I get this value of undefined. But if I plug negative 1.57 into my calculator, I'm just going to get negative 1,256. So using the unit circle, a little bit of calculator work, but mostly the unit circle to help me figure out what these points are. And this is exactly the same technique that we did for sine and for cosine. Okay, so using these points, I can then, and I'm going to get rid of this, I can then plot these points and graph them, according to the points that we just found. So 0, 0 is a point. Okay. And as always, I'm going to make my 4 tick marks. 1, 2, 3, 4. However, the total period for sine and cosine, if we remember, was 2 pi, right? So that 4th tick mark was 2 pi. However, for tangent and cotangent, it's pi. And I'll show you why, right? So this guy, let's say, has a tangent of 1. This one has a tangent of negative 1. This one has a tangent of 1. And then this one has a tangent of negative 1. So you only have to go 180 degrees before you get back to the same tangent, right? So if I have a tangent of 1, I do 180 from that and I get back to 1. And then I do 180 again and I'll get back to 1. Same thing if I'm starting at negative 1, I only have to go 180 to get to negative 1. So that's why the period there is pi instead of 2 pi, because 180 degrees is pi, right? So the fourth tick mark here is pi. So just kind of keep that in mind, okay? That means that my second tick mark is pi over 2, and so on and so forth. And I'm actually going to skip one here and call this 1 and call this guy -1, just to kind of spread it out a little bit more. And then I can go in the other direction, 4 tick marks. And this would be negative pi, and this would be negative pi over 2. And I'm going to use a different color here to graph. Okay, so if I start plotting points, 0, 0 is a point. Pi over 4, which is this tick mark, is at 1. Pi over 2 is undefined. Well, what the heck does that mean? Remember that undefined, whenever I have undefined, what that means is it's an asymptote. Okay, it's an asymptote. So let's make a little note of this. So asymptotes at x values which cause undefined y values, right? So pi over 2 gets me undefined, so that is an asymptote. So that's why this value kind of was really important. It shows me that as I approach pi over 2, my graph is increasing extraordinarily, right? So this is really going up to infinity. It's approaching the asymptote going up towards infinity. Then at negative pi over 4, I'm at -1. At negative pi over 2, again, I have an asymptote because it is undefined. And again, that's why this point was so helpful. It's because it's showing me that it's going down to negative infinity. And that is one period of tangent. So this is one period. And then after that, it just repeats. Okay, so I can go a couple more tick marks, 1, 2, 3, 4, right? So then here I have another asymptote where I have 0, 0 in the middle, and then +1, -1. And the graph comes up, goes through, and so on. So there would be another period, again here, you know, and just like sine and cosine, it goes on forever. So that would be our graph of tangent, okay? So just remembering that anytime you get undefined, which is at pi over 2 and negative pi over 2, those are your asymptotes. Those are kind of the boundaries for that one period of tangent. I am going to have to erase this to fill in the bottom part, which is kind of unfortunate. Actually, let me try something. It's just going to be very, very confusing. Yeah. Okay, so I'm going to have to erase it. And let's just see if we can go through the domain and range of this using what is drawn on your paper. Okay, so the domain. Remember that I have these asymptotes. That's not where the asymptote was. I have an asymptote 1, 2, 3, 4. So my asymptote was at pi over 2, which is here. There we go. So that means anytime I have pi over 2, there's no value there, right? So we can say that x cannot be pi over 2, right? But then if I add another pi, this was pi over 2. If I add another pi, I have 3 pi over 2, and that was where I couldn't have another one as well. So if I add pi I get this, right? And then if I add pi again, I get the next one. If I add pi again, I get the next one, and so on and so forth. So we say pi n, where n can also be negative numbers, right? If I subtract pi, I get here at negative pi over 2. And if I subtract pi again, I get out here at negative 3 pi over 2, right? And so on and so forth. So I start at pi over 2, and either I add pi every time or I subtract pi every time. And those are all the values that x cannot be, because that is where the asymptotes are. Okay? So we say pi over 2 plus pi n, because it's every pi in either direction. And then we always have to say where n is an integer, right? N is a whole number. I can't multiply by 0.5 or anything like that, right? Because it is always every pi, because pi is the period of tangent, okay? Then my range, what outputs, what am I allowed to get? So my graphs are going all the way down to negative infinity, and they're going all the way up to positive infinity. So here, y is in the set of all real numbers. I can have anything I want for my range. You also can write this as negative infinity to infinity, but I kind of like the top one better personally. Period. Okay. How long until it repeats itself? How long from start to finish does a tangent graph go? And hopefully we see that it's 1 pi, right? From negative pi over 2 to positive pi over 2 is 1 pi. Or from pi over 2 to 3 pi over 2 is 1 pi. Remember that sine and cosine were 2 pi. I took all the way around, but pi only goes halfway around the circle. Symmetry. Okay, what does the symmetry look like on this? So this has, that's my dog yawning. This has a rotational symmetry around the origin. So if I were to rotate the graph around the origin, it would land back up on itself. And if we remember back to last semester, that means that this is an odd function. So tangent is an odd function. Vertical asymptotes. Where are the vertical asymptotes? Well, I know that there is one at pi over 2. I know that there's another one at 3 pi over 2. So if I add pi, and then there's another one at 5 pi over 2, at 7 pi over 2, right? And I can keep going. So this is pi n. Okay, so the vertical asymptotes are every single value that x is not allowed to be. So that's why the domain and the vertical asymptotes are so similar, right? This is saying, hey, I have a vertical asymptote at every single one of these spots. Therefore, those numbers are not allowed to be part of the domain. And then my x-intercepts are, where does the graph cross the x-axis, right? So the first one in my first period crosses at 0, right? Crosses at the origin. There's that point 0, 0. There's also another one at pi. So if I add pi to that, then there's another one at 2 pi, and then there's another one at 3 pi, right? So it's pi n. Again, where n is an integer, so you can be adding pi or you can be subtracting pi. So 0, pi, 2 pi, 3 pi, so on and so forth, or at 0, negative pi, negative 2 pi, negative 3 pi, so on and so forth. And you don't have to write the 0. I was just showing you that's where we're starting. So x equals pi n is okay too, where n is an integer. So again, you can't have any decimals or fractions or anything like that for n. Okay. Okay, so let's look at the equation of tangent and see how do we move it left, right, up, down, all that fun stuff. Okay, so graph variations of tangent. Here is my parent graph of tangent. Okay, vertical asymptotes occur at, remember our original of our parent graph vertical asymptotes is pi over 2 and negative pi over 2. So if the graph has been moved left or right, those values can change, but my original ones are positive pi over 2 and negative pi over 2. So I take whatever's in my parentheses and I set it equal to those two starting points. Just like we did with sine and cosine, where we set it equal to 0 and we set it equal to 2 pi, it's the same thing. We're setting it equal to negative pi over 2. We're setting it equal to positive pi over 2. So this right here is super helpful. Okay? The x-intercept is halfway between the asymptotes. So if you know where the asymptotes are, x-intercept is going to be right in the middle of it. 1/4 and 3/4 of the way, the coordinates are negative a and positive a, right? Whatever a is, that's like your amplitude, okay? So whatever a is, maybe instead of negative 1 and 1, it'll be at negative 3 and 3, right? Or whatever, depending on the value of a here. And then you just, once you have one cycle drawn, you just go left and right with the same thing. Other thing to note, remember for sine and cosine, the period was 2 pi divided by b. Well, now the period for tangent is not 2 pi, it's pi. So the period is now pi divided by b. Okay, so this is another really important thing to note. So we're going to do a couple examples of how tangent can be moved around, left, right, up, down, things like that. And then we will move on to cotangent. Okay, so here's the first one. Sketch the graph of y equals x divided by, or y equals tangent of x over 2 by hand. Again, as a reminder, I know that we forget this a lot. This is the same thing as 1/2 x. Okay, so if this helps you see it better, just know that these two things are the same, okay? So I just want to kind of go through this. So the amplitude, quote unquote, right, the number in front of tangent is 1. So that tells me that my values are going to be at 1 and negative 1. And I'm going to draw my 2 tick marks. Wow, 4 tick marks. There it is. And I'm going to draw my 4 tick marks. And I'm going to kind of go through this. I'm going to have an asymptote. I know that this graph has not been moved left or right. And I know that because there's not a plus or minus inside the parentheses. Okay? So I feel confident in graphing an asymptote on the second tick mark on either side of the y-axis. I do not know what I'm labeling that is as yet, but I know that that's where the asymptote is. So let's find what those are. So again, remember, I graph it the same every time. I just label it differently. Okay, so to find my asymptotes, I'm going to set whatever's inside the parentheses, which is 1/2 x. And I'm going to set it equal to the original 2 asymptotes of the parent graph. One of those 2 asymptotes is pi over 2. And the other one is negative pi over 2, right? On the previous page, the parent graph of tangent that we graphed had an asymptote at pi over 2 and negative pi over 2. And I'm going to solve for x. So I'm going to multiply by 2, multiply by 2. These cancel, and I get 1x, or just x, equals 2 pi over 2, right? 2 pi over 2. So x is equal to pi. So that tells me right here that I can label this asymptote pi. I'm going to do the same thing here, multiply by 2, multiply by 2, and I get x is equal to negative 2 pi over 2. So x is equal to negative pi. So I can label this asymptote negative pi. Okay, so see, it's the same graph as the parent graph on the previous page. I just labeled it differently. I labeled it what it is now because the period has changed. Right now the total period is now 2 pi instead of 1 pi. just because the equation has changed. Okay, so I know halfway in between is going to be at 0, 0. I know that 1/4 of the way from left to right is going to be at -1 because there's no number in front of tangent. It's just 1. And then 3/4 of the way it's going to be at +1. And then I can just connect it and draw. And then I can just repeat it, right? 4 more tick marks. I can draw my asymptote, right? And from here, then it's just repeating the same thing over and over and over again. You really just need to make sure that that first period is labeled very, very, very well, right? So if this is pi, this is 2 pi. This is pi, or excuse me, -pi. That means the graph is doing something like this. So I'm just extending out to multiple periods. Okay, let's look at another one, a little bit more difficult. And then we'll switch over to cotangent. Okay, so this says, sketch the graph of y equals -3 tangent 2x by hand. Okay, so first of all, this tells me that I have an x-axis reflection because it's negative. That's okay, we can handle that. Okay. And then the 3 gives me a vertical stretch. So, quote unquote, my amplitude is 3. So instead of at -1 and 1, it'll be at -3 and 3. Okay, and then because of this 2x, my asymptotes are at a different spot. So again, and I have not moved left or right, and I know that because there's not a plus or minus here inside the tangent. So I feel confident doing 2 tick marks over and drawing an asymptote, and then 2 tick marks over, and then drawing an asymptote. I have absolutely no idea what I'm labeling those asymptotes as yet, but I know that they're there. So let's figure it out. All right, so my asymptotes, I'm going to take what's inside my tangent, which is 2x. I'm going to set it equal to the parent graph asymptotes. So the parent graph asymptotes are 2 pi and negative. Oh, I said 2 pi, sorry, pi over 2. Okay, and we're going to solve, so divide by 2, divide by 2. And I get x equals pi over 4. Right? And then divide by 2, and I get x equals negative pi divided by 4. So that tells me this is pi over 4, and this is negative pi over 4. Okay? And I'm going to draw my tick marks. Let's call this 3. And this is -3. Okay, I know halfway between I'm going to be at 0, 0. There is no x-axis reflection for 0, 0. Okay. Down here I would be at -1, but because of the 3, I'm going to be at -3. And then because of the x-axis reflection, I'm actually going to be up here at +3. Same thing here at pi over 8. Normally I would be at 1. Because of the 3, I would be at 3. And then because of the negative, I'm going to be down here at -3. So it's just reversing the direction that the graph is going. Okay, so instead of increasing from left to right, it's now decreasing from left to right. I can keep going, right? Draw my asymptote. This is pi over 4. This would be 5 pi over 4. And I can just repeat. You can hear my dog whining. Perfect. So just drawing as many periods as will fit. Okay, so hopefully that makes sense. Again, reach out if you have any questions. We are going to move on to cotangent. So we have the three main done, right? The three original: sine, cosine, tangent. Now we're going to go into the reciprocals of those. Excuse me. So the cotangent, the cosecant, and the secant. So let's start with cotangent, since we just did tangent. Makes sense. Okay, again, using the unit circle. And we can do it this way if you want. This is the point 1 comma 0. Remember, cotangent is x over y, so this would be 1 over 0, which is undefined. You cannot have 0 on the bottom of a fraction. So that tells me at 0, it's undefined. Well, I know that that's going to be an asymptote. Okay. Pi over 4 is root 2 over 2, root 2 over 2. So when I divide those, I get 1. Pi over 2 is the point 0 comma 1. So x over y is 0 divided by 1, which is 0. 3 pi over 4 is right here. And that's going to get us negative 1. And then at pi, it's going to be the same thing, undefined. So I'm going to draw my 4 tick marks. And this is going from 0 to pi, so I'm going to label this 4th tick mark pi. And at pi, it is also undefined. So I also know that there's a asymptote there. Okay, I know halfway, which is pi over 2, is 0. And then a quarter of the way, which is pi over 4, is 1. And then 3/4 of the way, it's negative 1. So this looks an awful lot like the one we just did, right? Negative tangent. Okay, same idea. And then again, this just repeats. And, we can just have it repeating, blah, 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 right? 1, 2, 4. So again, just worry about that first period, and then everything else will kind of just repeat. Not kind of, it will repeat. Okay, so let's look at the domain here. So the domain, my x values, right? So I see x values that I'm not allowed to have. I'm not allowed to have 0 because there's an asymptote there. Not allowed to have pi because there's an asymptote there. So x cannot be 0. X cannot be 0 plus pi, right? It can't be 2 pi, it can't be 3 pi, it can't be negative 6 pi, right? So we're going to do the pi n again. And we can, you don't have to write the 0, but you can if it helps you. And again, where n is an integer. So it has to be a whole number. It cannot be, it can be positive, negative, 0, but it cannot be fractions or decimals. Okay, so I can't have 0. I can't have 0 plus pi. I can't have 0 plus 2 pi, right? That's what the n is, if n is 2. Can't have 0 plus 20 pi if n is 20, right? It doesn't, those are values I'm not allowed to have. For my range, I go all the way down from negative infinity up to positive infinity. So my range here is all real numbers. The period, how long does it take to go from one asymptote to the other? We go from 0 to pi, so the period is pi. There is rotational symmetry around the origin, so this is an odd function. So the only one that's even actually is cosine and cosecant. Okay, asymptotes. Where are the asymptotes? There's one at 0. right? There's one at 0 plus pi. There's one at 0 plus 2 pi. There's one at 0 plus 20 pi. So we got that pi n again. So again, you don't have to write the 0. So x is equal to pi n. Again, where n is an integer. And then the x-intercepts, where does the graph cross the x-axis? So x-intercepts are at, my original parent graph one is pi over 2. And then I'm adding pi every time, right? So the next one would be plus 3 pi over 2. And the next one, right, would be 5 pi over 2, and so on and so forth. So this is plus pi n. Again, n is an integer. It's really annoying that we have to keep writing that, but we do. Okay, so this is just saying, hey, it crosses the x-axis at pi over 2, and then every other multiple of pi going in both directions. Whew! Right, decompress. Let's take a look at the equation of cotangent and the modifications, and then we'll practice a couple graphing. Okay, so let's look at the equation for cotangent. Really similar to tangent, right? Here's the parent equation. X-intercept is halfway between the asymptotes. The period is the same instead of 2 pi over b, right? It's just pi over b because the period of cotangent is pi. This is the only place where it's different, right? We just set whatever's inside the parentheses equal to the parent graph asymptotes, right? So where are the new asymptotes? Well, you set the parent graph asymptotes equal to whatever's in the parentheses. So for cotangent, the parent graph asymptotes are 0 and pi. Okay, my dog is very vocal tonight. I'm sorry. Okay, so 0 and pi. So this is where it gets a little tricky, right? Is we just have to kind of remember signing, like where does sine start, where does sine end? Where does cosine start, where does cosine end? Where does tangent start, where does it end? Where does cotangent start, where does it end? And that's really those four that we really need to make sure that we know, okay? So sine and cosine go from 0 to 2 pi. Tangent goes from negative pi over 2 to positive pi over 2. And then cotangent goes from 0 to pi. So, I mean, that's really like the kind of point where we're like, okay, we need to just kind of know it. But other than that, it's pretty much identical to tangent. So we're just going to jump into the example. So here it says sketch the graph of y equals 2 cotangent of x over 3 by hand. So again, if that's like really throwing you off, remember you can always write this as cotangent of 1/3 x, if that helps you, okay? The 2 here has my vertical stretch. So instead of going from -1 to 1, it's just going to go from -2 to 2. Okay, so this has not been moved left or right, and I know that because there's no plus or minus, right? So I'm going to draw my asymptote at 0. I'm going to draw 4 tick marks, and the fourth one is going to be my last asymptote. However, I'm not going to label this yet because the period has changed because of this pi over 3, or x over 3, okay? So to find the asymptotes, I need to set whatever's inside the parentheses, which is x over 3, equal to the first parent graph asymptote, which is 0, and the second parent graph asymptote, which is pi. And I'm just going to solve. So, right, times 3 times 3. So x equals 0. So again, right, feel pretty good about where I drew that asymptote. Here times 3 times 3. So x is equal to 3 pi. So this right here, instead of being labeled pi, it's going to be 3 pi for this problem. Vertical x-intercept is right in the middle of the vertical asymptotes. I'm going to call this guy 2, just because I want to spread it out a little bit. So cotangent halfway is up here at 2. and then in the middle, and then down to -2, and I just connect it. Did you have to skip every other tick mark? No. Okay, it doesn't matter as long as you label it very, very, very well. For the sake of time, I am not going to draw the other periods here, but I think that you should in your notes. So if you need to pause the video and do that, then please do so. But I am not going to for the sake of time for you watching this video. So let's look at our next example. Okay, next example of cotangent, or last example of cotangent. Let's see, I have a vertical stretch of 3, right? This right here tells me that I have moved left or right because of this plus. Hopefully, does that make sense? Okay, so the period, so now I gotta figure out the period. The period is always pi over b. Well, in this case, the number in front of x is 1. So I get pi over 1, which is just pi. So the period is still pi, so that's good. Okay, but I've moved to the left or to the right, and in this case, I've moved to the left because it's plus. So I am not going to draw any asymptotes until I figure this out yet. Okay, so I'm going to set what's inside the parentheses equal to my original parent graph asymptote, where 1 is 0, and my other parent graph asymptote is pi. And I'm going to solve. So I'm going to subtract pi over 4. So I get x equals negative pi over 4. So there's one asymptote. Here I'm going to subtract pi over 4. So pi is 4 pi over 4, just to do some quick mental math fractions, right? So I should get 3 pi over 4. So here are my new asymptotes. So the whole graph has been shifted to the left. So instead of going from 0 and then 4 tick marks and then asymptote, I'm going to go left 1. I'm going to call this negative pi over 4. And then I'll go 1, 2, 3, 4, and draw this one. And that'll be 3 pi over 4. So notice because this graph has been shifted left, I did not automatically draw my asymptotes. Okay, I wanted to see where they were going to end up first. Okay, so halfway between is 0, so here's 0. I do have a vertical stretch of 3, so 3, so here's 3, 1, 2, 3, negative 3, right? So a quarter of the way, so it's going to go through here at 3, and then 3/4, it's going to go negative 3, and then this is just a graph that approaches my asymptotes like so. Again, for the sake of notes, I would draw the other periods of this, but I am not going to do it on the video just because I think that you guys can do that on your own. Again, if you have any questions on tangent or cotangent, you need to make sure that you reach out because what we're going to look at next is secant and cosecant, which as long as you know sine and cosine, secant and cosecant, just follow along with it and you'll be just fine. Okay, so let's look at those now. Okay, so we are going to look at the graphs of cosecant and secant. And basically, just as a reminder, and I'm going to use 2 colors here, so I would highly recommend if you are able to maybe use 2 different colors. But I just want to remind you that cosecant is the same thing as 1 over sine of x. So as long as you can graph sine of x, you can graph cosecant of x, and I will show you what that means, okay? So what we're going to do first here is we are going to graph sine of x. So I'm going to do 4 tick marks, right? So that's a full period. I'm going to label this 2 pi because that is the period of sine. Okay, and then I'm going to do double. I'm going to call this one. and this one -1, just because I want this graph to be a little bit more visible. Okay, and what we're going to do is we are going to graph sine. So here's sine. So here is one period of the sine curve. So I'm going to go up and then down. Whew, okay. So there's sine, right? I'm going to keep going because we never really want to just, I don't know why I put that point there. Sorry. We never just want to do one of those, right? We always want it to keep it going. Okay, so there's that, and then let's go in the other direction as well. So you want all of sine, you want this whole graph to be filled out with the sine graph. Hopefully we're feeling pretty good at this point about graphing sine, at least the parent graph of sine. Okay, more or less, something like that. Okay, and this is where I'm gonna switch colors. Okay, so remember that, and I probably should label this, right? Y is equal to sine of x. So cosecant of this is the reciprocal. It's the reciprocal of these points. So let me kind of go through with you what that means. So let's say right here, the reciprocal of 1, right? That is the y value. The reciprocal of that, the reciprocal of 1 is just 1, right? So 1 over sine is just 1, so that stays. At 0, if I have 1 over 0, that's undefined. What happens when it's undefined? You have an asymptote. Oh my God, that brain is blood, right? So anytime that this graph crosses the anytime that this graph crosses the x-axis, it is an asymptote because I cannot have 1 over 0. Okay, right here, right? The output is 1. That would be 1 over 1, which is just 1. So that just stays. Oh, here's 1, 2. So I'm missing some asymptotes. Same thing here. At this point, this is -1. So 1 over -1 is just -1. So this point also stays. So what happens is as soon as you draw those asymptotes, the peaks and the valleys of sine stay, and your cosecant graph just approaches those asymptotes. Okay, so it just makes these. They should be more like U's, but I'm drawing them real fast here. Okay, so cosecant is just the green graph. So what I do personally is if I'm asked to graph cosecant, I do sine, I graph, the peaks and valleys and everything, and then I erase sine. Okay, so then basically, and I don't want you to erase it in your notes, but just so I can show you, then you would go and erase these guys. And so I use sine as like a guiding point for me. I'm like, okay, I know it's the reciprocal of sine, so I'm going to graph it. I'm going to graph sine and then just use that as a guide. So then just the green graph there, that is the graph of cosecant. And then secant is exactly the same thing, which is kind of cool, right? So secant is the graph 1 over cosine. So if you can graph cosine, you can graph secant. So I would draw my 4 tick marks, label it 2 pi, and secant starts at 1. So it goes here. And again, you want to just keep going with that. You want to draw the whole length of the graph. I'm just very quickly doing this, so I know it's not the best, and I apologize. Make yours prettier than mine, right? Okay, so there's the graph of cosine. So now, right, it's the same thing. If I take this green, anytime this graph crosses the x-axis, it's an asymptote, right? Because here I would have 1 over 0, which is undefined. And here I would have 1 over 0, because the output is 0. So it's undefined. So here's undefined. Right? So anytime that this graph crosses the x-axis, I have an asymptote. And then guess what? It's exactly the same thing. You take your peaks and valleys and you approach your asymptotes. And then similar to cosecant, when you are done graphing secant, then I would go through and I would erase cosine so that you just have something that looks like this. So the nice thing about secant and cosecant is that, and again, you don't have to erase this in your notes, and I would not erase this in your notes. I just want to show you. So the good thing about graphing secant and cosecant is that you don't really have a whole lot that you have to memorize. As long as you can graph sine and cosine, you can graph cosecant and secant because it's the same graph, right? It's just taking the graph of your sine and cosine and just basically flipping it and inverting it. Okay, so we're going to look at the characteristics of these two graphs. And again, I cannot fit it all onto one page, so I'm going to have to erase this. So look at your drawings while we go through the characteristics of this. Okay, so the period for both of these is the same as sine and cosine. So it's 2 pi. Okay, the period of sine is 2 pi, so cosecant is 2 pi. The period of cosine is 2 pi, so secant is 2 pi. Domain. Now we have asymptotes, right? We just drew a ton of asymptotes. So that tells me that x cannot be. One of my asymptotes was at 0. And then every other asymptote was 1 pi away from each other. So it'll be 0 plus pi n. Or you can not write the 0 and you can just write pi n, your choice. Right? And then n is an integer. Don't forget to write n is an integer for all of these. So you can have any value you want, you just can't have where those asymptotes are. My range, okay. So if we start on the bottom, what's the lowest this goes? This goes all the way down to negative infinity, and then it goes up, up, up until negative 1. And there's a bracket at negative 1 because I do have a point at negative 1. And then there's nothing, right? There's nothing. We're just looking at those green ones, right? There's nothing, nothing, nothing until we get to 1, and there is a point at 1, and then that goes up to infinity. So that is my range. There's nothing there between negative 1 and 1. Where are my vertical asymptotes located at? Same place that my domain is not, right? So x equals pi n. N is an integer. Oops, my pin's getting all stuck. There we go. And then symmetry. What kind of symmetry does this have? So this actually has rotational symmetry. Rotational symmetry around the origin. So anything that has rotational symmetry around the origin is an odd function. So that is for cosecant. For secant domain, again, I have asymptote. So there's values that x is not allowed to be. My first asymptote here is located at pi over 2. Right, so at pi over 2, I kind of look at like the first positive one. So I don't usually start with negatives, but you can. Okay, so pi over 2 plus, and then there's an asymptote every pi. So I can go pi n. Again, n is an integer. Do the n is in the set of all integers. Wow. So that's a z. It's really hard for me to do on here. There you go. So that's the symbol that I was attempting to draw. That was not very good. Okay. Range. Okay, so again, I come up from negative infinity. I'll go all the way to -1. And then I skip over. The U just means union, so like with. I skip everything over until I get to 1, and then I go back up to the infinity. So the range there is the same. My vertical asymptotes occur where my domain values don't. So right there, pi over 2 plus pi n. Again, n is in the set of all integers. And then symmetry. So this one actually has reflectional symmetry, right? It's cut right in half on the y-axis. So this is reflectional symmetry on y-axis. So this is the only one that's different. So this is an even function. So cosine and secant are the only ones that are even. All the other ones are odd. Okay, so let's use this information to graph sine. So a function in sine and then a function in cosecant. Alrighty, so let's look at example 4. It says use a graphing utility, but we're going to graph this by hand so we get practice with it, okay? So I have essentially the same equation here. Just one is a sine function and one is a cosecant function. So let's focus on graphing the sine of this. And then once I have the sine graphed, the cosecant should be really quick. Okay, so again, I'm going to use a couple colors. So I'm going to use purple for sine. So the 2, I'm going to go down the list, right? So my amplitude here is 2. So instead of going from -1 to 1, I'm going to go from -2 to 2. Okay, the period is going to be 2 pi divided by b. And if we remember here, b is the number in front of x. So in this case, it's 2 pi over 1, which is just 2 pi. And then this has been shifted left and right. So I'm going to take what's inside the parentheses, and I'm going to set it equal to my original starting point for sine, which is 0. And I'm going to set it equal to my original ending point for sine, which is 2 pi. Okay, so I'm thinking about parent graphs here. And I'm going to solve. So here x is equal to -pi over 4. And then here I get 2 pi with a denominator of 4 is 8 pi over 4 minus 1 pi over 4 is 7 pi over 4. So hopefully that makes sense how we got that. And I still like to do everything in terms of 4 tick marks. So I'm going to go 1 over, and that's going to be my -pi over 4. And then I'm going to go 1, 2, 3, 4, and this is going to be my 7 pi over 4. So again, I'm graphing everything the same. I'm just changing the way it's labeled. Okay, and then my amplitude is 2. So 1, 2. So I'm going to call this 2, 2, and this one -2. Okay, then I have to ask, does sine start at 0 or does it start at 1? And sine starts at 0, so that tells me that it's here, and then up to 2, and then here, here, here. So here is 1 period of my sine graph. Okay, and then we're going to go ahead and extend this out. Okay, so here is my sine graph. So now I have graphed 2 sine of x plus pi over 4. We did it, yay, right? Now, if I would want to graph, let's try to not do one that hurts our eyes so much. If I want to graph the same graph but the cosecant of that, what I would do is I would start with graphing the sine, just like we did. And then again, anywhere that this graph crosses the x-axis is an asymptote. Okay, I know that that is going to be an asymptote, so I can draw in those asymptotes, just like I'm doing. And then I'm just going to take my peaks and my valleys, and I'm going to send them towards the asymptotes, just like so. In this problem, I would not erase the sine graph because they wanted you to graph both. If I just asked you to graph cosecant or I just asked you to graph secant, then I would maybe erase the other one. But in this case, because it asks you to graph both, we're going to leave both on the graph. Okay, we're going to do one more like this, and then we're going to do some review stuff, and it's going to be so fun. I'm excited. Alrighty, so very, very, very similar. Use a graphing utility. Now we're looking at cosine and secant. And then I want to make this clear. This is kind of a typo-ish. So notice how there weren't parentheses around the 2x and the 3. So because the 3 is not clearly in with the cosine, you have to assume that it's just cosine of 2x minus 3. Okay, so I just want to make that like super, super clear. Okay, so let's start with graphing cosine. The amplitude, the number in front of cosine is just 1, so that's good. The period, so how long does it take to go from start to end, is always 2 pi over b. In this case, my b is 2, so I get pi. Now there is a vertical shift because of that minus 3, right? So it's down 3. And it has not been moved left or right because there's no plus or minus inside the function, right? So I don't have to worry about it moving left or right. So that's good. Okay, so I am going to take my x-axis, and I'm going to, again, do it in purple. So 1, 2, 3, 4. And then my amplitude is 1. I'm going to go every other, if that's okay. So normally it would be here. So there's 1. Here is -1, -2, -3, -4. Okay. So normally, because it's cosine, I would start here. But I have a shift down of 3. So I have to go down 1, 2, 3. So now I'm going to start here. Okay. Then I would go down here, but I move down 3. 1, oh gosh, 1, 2, 3. Okay, and then halfway, I would be down here at -1. So 1, 2, 3. Here I'd be back at 0. 1, 2, 3. And here I'd be back at 1. So 1, 2, 3. So if you notice, and I want to kind of do like a super light color, because it, oh, that's really light. Ugh. Because it's been moved down 3, this is kind of my equilibrium. This is kind of like my new x-axis, if that makes sense. So then I can just keep going that way. So then it'd be here and here, right? And I can just keep graphing it, kind of using, that yellow line as a guide, okay? So here is my graph of cosine of 2x minus 3. So the fact that it's been moved down, it has a different period, which I did not label on the x-axis, my bad, right? So the period here is pi, so this is pi instead of 2 pi. But there's my graph, so there's cosine. Now, again, to find sine, or to find secant, I just take any time it crosses the x-axis, right, the equilibrium, and that is going to be my asymptotes. So I'm going to draw all my asymptotes like so. And then just take all my peaks and valleys and have them approach the asymptote. So just because it's been moved down doesn't mean it's not graphed exactly the same. It is, it's graphed exactly the same, it's just been moved down. Okay, hopefully that makes sense. If you guys have questions on how to graph the any of these 6 trig functions, just make sure that you're continuing to reach out for help and things like that. We are not going to do damped graphs. So we're going to go to the last page in this section. Let's scroll down. So we are not doing these guys. And so we're going to go here to the application exercise and then the mixed review. Okay, so on this application problem, it says the angle of elevation from the top of a house to a jet. And remember the angle of elevation always has to be from a horizontal. If I draw like a horizontal here, this is the angle of elevation. And that can be really confusing. So remember, it always has to go from the horizon, like from a horizontal line, up. Okay, so backtrack. The angle of elevation from the top of a house to a jet flying 2 miles above the house. So the jet is 2 miles above. And the angle of elevation is x. Okay? If d represents the horizontal distance in miles of the jet from the house, so this is then d miles, express d in terms of a trig function and then graph it. Okay, so when I look here, here's my angle. The angles I have are, or the sides I have are opposite and adjacent, right? So opposite and adjacent is tangent. So I can say that tangent of my angle, which is x, is equal to opposite over adjacent. So there I have the trig function. However, it wants me to express d. So I want to get d by itself. Okay, so I'm going to multiply both sides by d. So I have d times tangent of x equals 2. And then I can divide by tangent of x. Okay, so I get d is equal to 2 over tangent of x, which is awesome. So I express d in terms of a trig function, then graph it. Okay, so my thing here is that I don't know how to graph a trig function when it's in the denominator, right? It's down here in the bottom. So what I'm going to do is I'm going to kind of split this up. I'm going to say this is 2 over 1 times 1 over tangent of x. And hopefully that's okay how I got that. I literally just split this fraction up. Okay, and then 1 over tangent is cotangent. So this is really 2 times cotangent of x. Well, I know how to graph that, right? Because now I no longer have a trig function in the denominator. So I know how to graph this. So I know that there's been no left or right shift. So I know that there's going to be an asymptote here at 0. Then there's going to be 4 tick marks and another asymptote. I just don't know what I'm going to label this asymptote yet. So let's figure that out. So my asymptotes are at, you take whatever's inside the parentheses and set it equal to your original parent graph asymptote, which is 0 and pi. So x is 0, x is pi. So this is just pi. Okay. And then I can graph. I know that halfway in between would be 0. Normally halfway or a quarter of the way would be at 1. But here I have a vertical stretch of 2, so we'll go up to 2. And then 3/4 of the way normally would be at -1, but because of that vertical stretch, it's at -2. So I'm just graphing a cotangent, something like that. Okay. And notice right here, it says graph the function from 0 to pi. It does not want me to graph anything past pi, does not want me to graph anything below or before 0. So it'll just be this one period. Okay. As for this assignment thing, you can cross that off. You guys don't need that. Your assignments are on the assignment sheet or you know, on the platform as normal. The last thing we're going to do is mixed review, which is more you guys try it, and then I will put the answers up so you can check your work. So here we have a factoring by grouping, a log problem, and an exponential problem. So go ahead and try these on your own, and then when you're ready to review them, you can hit play. Okay guys, so here's the answers for all 3 of these. If you need to pause the video at any time to check it, just please make sure you do. For A, we just factored by grouping. So we took out the greatest common factor of the first 2 terms and of the last 2 terms. And then I was able to get x squared minus 4, x plus 5, but x squared minus 4 factors again to x plus 2, x minus 2, x plus 5. So I got 3 answers for this one. For B, our logs, remember that I can combine this into one log if I multiply. So I'm multiplying x by x minus 2, which I did here. And so that's how I got x squared minus 2x. I distributed that x. Since I only have one log on each side or one side, I can raise this to the base of 2. Okay, so that cancels my log. So that gets me x squared minus 2x. And then 2 to the third is 8. I moved the 8 over to the other side, and I factored, which got me x equals 4, x equals -2. Remember that you are not allowed to take the log of a negative number or 0. So 4 works when I plug it back in, but -2 does not. So 4 is my only answer here. And then for C, I want to get rid of this e, so I took the natural log of both sides, which cancels out the e. So that's how I got 0.04x equals the natural log of 4,500, divided by both sides by 0.04, and then I entered it into my calculator to get about 210.3. If any of these are going wrong for you or you have any questions or anything like that, make sure that you reach out. If you have questions about anything in this unit or in this lesson, make sure that you reach out. I know that it was a lot of information, a lot of graphing. It's not easy, so just make sure that you're getting the help that you need. I will see you guys next video.